Assalamualaikum doktor. My name is AMARAH binti Razlan. My number is.
My name is DANIA HALISA binti Mawar Azri.
My name is SITI ALYSHA binti Suhaimi.
Okay, so we are group objects, and today we will present our project, which is Surat. So, as you know, Surat is 2D endless random game that developed using C++. The objective of the game is for the player to collect coins to increase the score while avoiding obstacles such as rock and flowers. So the player also need to collect items which activate a temporary speed boost effect for 5 seconds. Okay, so in this presentation, we will explain our project structure, demonstrate the gameplay, and show how we implement the OMP concept required for this development. So first, we look at our project structure. We have the main folders, which is game, players, moving object, score, location, and asset. So for the game, which contain the main game logic. So the player, for player, it store the player class, and moving object contains all moving object in the game. For which is reward and obstacle. So the reward contains coin and egg, and obstacle contains the rock and flower class. So for the next is score, which means the player score, and location, which store the position of moving objects. The moving object is reward and obstacle, and the last is asset. Asset which contain the image of the game, background, game over screen, okay, and all other egg, flower. So next, by the way, each class has its own header file, which is HTTP, and implementation file, which is CEP. These follow for proper code organization by separating the class declaration from its implementation. So this will be making the project easier to understand and maintain. So next we will compile and run our project. Okay, so next we will compile and run the program. So check time. Okay, now we go to gameplay demonstration. Okay, so the player will control the character by pressing the space key to jump. So the objective is to collect coins while avoiding the obstacle. Okay, every time the player collects a coin, the score increases by 1 each. So the player also can collect an egg where it is collect. A speed boost effect is activated for 5 seconds. So during this period, the text speed boost active is displayed on the screen to indicate that the effect is active. So I think that's all. So I will pass to my next member.
Okay, so now we will explain about the object-oriented programming concept that used in our project. And so the first concept is encapsulation. So encapsulation means keeping the data and the functions that operate on the data inside the same class. So it also helps to protect the data from being accessed or changed directly from outside the class. So in our project, encapsulation is implemented in every class. For example, in the player class. So in the player class. Alright, so the attributes such as X, Y, size, jumping, and velocity Y are declared as private. Yeah. Okay, so this means these attributes cannot, so these attributes cannot be accessed directly from outside the class. So other classes cannot simply change the player's position, size, or jumping status without using the correct methods. So instead, the player class provides public methods such as get X, get Y, and get size. So these methods allow other classes to get the player's information in a controlled way. So besides that, the player class also contains methods such as jump, update, and draw. So these methods actually manage the behavior of the player. For example, the jump method controls how the player jumps, and the update methods updates the player's movement, and the draw method displays the player on the screen. So similarly, classes such as moving objects, score, reward, and other classes also encapsulate their own attributes and methods. So actually, each class is responsible for managing its own data and behavior. Yes. So the next OOP is the association. So association represent a relationship between classes. It means one class is connected to another class and they communicate with each other to perform a certain task. So in our project, the game class communicate with several other classes such as player, score, coin, egg, rock, and flower. So these objects work together to perform the game logic. For example, the game class needs to check the player's positions, update the score, display the objects, and detect the collisions between the player and the moving objects. So actually the game class controls the interactions between all these objects during gameplay. So this shows association because these classes are related and cooperate with each other, but each class still has its own role in the program. So the next concept is composition. Composition is a strong ownership relationship between classes. It means one class owns another class as part of itself. So in our project, the game class contains it contains player, and score. That one. Player, and score. So these objects are part of the game itself. So when a game object is created, the player and the score objects are also automatically created. So when the game object is destroyed, the player and score objects are also automatically destroyed. So this shows a strong relationship because the player and the score are directly included inside the game class. So in our project, the player and score cannot exist independently from the game object because they are part of the game structure. And the last concept is aggregation. So aggregation is a weaker relationship compared to composition. It means one class use another class, but the objects can still have their own existence. So for example, in our project, the game class also stores pointers to the moving object using moving object that were objects in bracket form. So these moving objects include coin, egg, rock, and flower. So the game class use these objects during gameplay. So for example, it updates their movement, draws them on the screen, and checks whether they collide with the player or not. However, these objects are created dynamically using pointers. They are managed by the game class during the game and deleted in the game destructor. So this shows aggregation because the game class does not contain the objects directly like composition. So instead, it stores pointers to them and manage them while the game is still running. So overall, aggregation allows the game class to work with different moving objects in a flexible way. So I think that's all from me. Next, I will pass to Tanya.
So next, I will explain the concept of inheritance. So inheritance allows a child class to inherit the attributes and methods from a parent class. So in our project, the inheritance hierarchy is as follows, which is moving object is the class, is the parent class, and then obstacle and reward inherit from moving object. So here, eh, me. So here it is, which the obstacle inherit from moving object, and also for reward is the same here. Then next example is rock and flower, which is it inherits obstacles, which is here and also here. And same as coin and egg, which inherits reward. And also this means that coin, egg, rock, flower automatically inherit the common attributes and methods defined in their parent classes. So, for example, every moving object has a location, movement speed, update function, draw function, and collision checking. So, instead of writing functions separately for every class, we decide to place the common behavior inside the parent class, which is moving object, and let the child classes inherit it. So, okay, so for the next concept is polymorphism. So polymorphism allows different objects to respond differently to the same function call. So in our project, the moving object class declares virtual functions such as move, draw, update, and also on collision. So as an example, for moving object. So this is the example, which is virtual void move, virtual void draw, virtual void update, and also for the on collision, which is it will check whether if there is a collision between object and player. So although they all use the same function name, each object performs a different action. So this also can be seen in our game class. So instead of calling each object's function separately, we store all moving objects inside a moving object pointer array and use a loop. So here, it is for update, and then this one's for draw, check, and then and then this for check collision and also on collision. So for example, if object 0 is a coin, like here, so coin draw is called, which is from here. If we call the coin draw using array object 0. So this is how polymorphism is implemented in our project. So we chose this approach because it reduces repetitive code and allows different objects to be managed using the same interface. So next is array of objects. So instead of creating separate variables for every moving object, we store all moving objects inside a single array. So it's as shown in our game class. So game HPP here, moving object pointer objects 4. So this array actually stores 4 different objects, which is coin, egg, rock, and flower. And each element of the array points to a different child class object. So for example, object 0 is for coin, object 1 for egg, object 2 for rock, and also object 3 for flower. So because all of these classes inherit from moving object, they can all be stored inside the same array. And this allows us to use loops to perform common operations. So in conclusion, our project successfully applies the OOP concepts required in this deliverable. So we already implement encapsulation by protecting attributes inside each class and accessing them through public methods. Next is association, aggregation, and composition to organize the relationships between classes. Inheritance to allow child classes to reuse common functionality from parent classes like reward, inherit, moving object. Polymorphism allow different objects to perform different actions through the same function calls. And lastly, array of object to efficiently manage all moving objects using loops. So I think that's all for our project presentation. Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.